Okay, this video is for lesson 6-2. So you want to find this page in your notes and start here at the bottom. This is where 6-2 starts. So exponential equations are equations in which the variable occurs as an exponent. Right, so we graphed them in 6-1. They always look like that. Your variable will be stuck up here as an exponent. So 6-2, we're going to start solving those. Now this right here is the most important thing. So put a star, put something around that so you remember that. So this says if the bases are the same, then the exponents can be set equal to each other. So for example, if you have an equation like this, 2 to the x equals 2 squared. If I told you to make those two equations, or the two expressions on each side of the equal sign, look identical, if I said change your paper right now to make these identical, you would put a 2 here to make them identical. So this is what this property says. It says if your bases are the same, remember the base is the big number that has the exponent attached to it. So if your bases are the same like they are here, base 2, and you have the equal in the middle, and these numbers are the same, it's only logical that x must equal 2. So our goal is always going to be to get our bases the same, and then we can set our exponents equal to each other. So remember, put that example in your notes. If I'm writing it, you should be putting it in your notes. So here we go, example 1, solve. So remember, whenever we're solving, we're going to find out what number x equals in these equations. So we're going to figure out a solution for x. Alright, so solve 3 to the 2x equals 3 to the 4. The base equals 3. Same bases. So first you want to check your bases. Remember, they're the big number that have the exponents. If they're the same, then you can take your exponents and set them equal to each other and write an equation that will let you solve for x. So this is how we take our variable that's stuck up in our exponent and get it down where we can solve it. Right? This is just an algebra 1 equation. To get x alone, I divide both sides by 2, and I get x equals 2. Say I wanted to check this. So if I think x equals 2, I want to go back up here and put a 2 in there. So I would end up with 3 to the 2 instead of 2 to the x. 3 to the 2 times 2, because I'm checking if when x equals 2. And then the question mark is that the same as 3 to the 4th? So remember, when you're checking, that's what I'm doing here, you're checking to see if you get the same number on both sides of the equal sign. Well, 2 times 2 is 4, so this is 3 to the 4th. That equals 3 to the 4th. So yes. So every answer you get, you can check. So these are the problems where you shouldn't get any wrong, because you can check it. Okay, here's another one. First thing I want to do is look at the bases. Base 4, equal sign in the middle. When I have the same base with the equal sign, you can almost think about it as I'm going to ignore these bases and I'm going to set my exponents equal. So I'm going to get 4n minus 2 equals 25. And then I'm going to continue to solve for n. So add 2 to both sides. That gets me 0 over here. 9n equals 27. Divide both sides by 9. N equals 3. Okay, I'm not going to take the time to check all of these in the video, but I recommend you do it. This is a your turn. This is a your turn. You should do those, and then, well, actually, I'll tell you what. Pause the video, try them, and then see if you got the right answer. So this one, you should get x equals 9, and this one you should get x equals 4/3. Okay, so try those. Alright, now, so those are the ones I've given you so far. You've already had the common bases. Now we're looking at this one. if you look at this, left side of the equal sign base 4, right side of the equal sign base 16. Remember, this has an invisible exponent of a 1. So this is, can you make the bases common? So on this one you have to change a base. And in this case we only have to change one base. So the question you want to ask yourself is, you always want to find the smaller base, which is base 4, and you want to check or think, can I write 16? So the question mark is, can I write 16 as 4 to the power of something? So that's where that exponential cheat sheet comes in handy. You want to find the column that has all the 4 to the x on your cheat sheet on it, and you want to go down that column and see if there's a 16 on it. So when you do, you see that 4 to the second power is equal to 16. So what I'm going to do here is, on the right side, instead of 16, I'm going to write it as 4 to the second power. So I'm rewriting 16 as 4 squared. Those are equivalent. Left side, I'm going to keep everything identical. So when we don't have common bases, we see if we can make common bases. So base 4, I'm good to go. 9n minus 2 equals 2. Ignore the bases. Set the exponents equal to each other. So add 2 to both sides, and I get 9n equals 4, divide by 9, n equals 4 over 9. You can keep these as fractions. You don't have to rewrite them as decimals. Okay, so this is your turn. You should try that. And what you want to, well, you can see that you don't have common bases because you have a base 2 and a base 4. So you always want to ask or check, can I write the bigger base in terms of the smaller base? So can I write 4 as 2 to the something? Okay, so you want to check your 2 to the x column on your cheat sheet and see if there's a 4 in it. Alright, I'm going to go on to this one. This is, I feel like you have a different one in your notes. Well, I'll do this one. I think you have a fraction one in your notes. I'll go back to that one. So this one, not common bases, but I know that 9 is the same as 3 to the second power. Now what you have to be careful about on this one is I'm rewriting 9 as 3 to the second power, and notice how I'm wrapping it up in parentheses. That's really important in this problem. Because this is true, 9 is the same as 3 to the second power, but this 9 already had an exponent on it. So I need to make sure I keep that exponent as part of the problem. So replace 9 with 3 to the second power and keep the exponent that was on 9. On the left side, I'm just going to copy job that. Now, way back when we first started looking at exponents, and we had something like this, when we had an exponent raised to another exponent, we multiplied the exponents. So that's what this is, an exponent raised to another exponent. So when I ignore my base 3's and set my exponents equal, on the left side I'm going to have 5x. On the right side I'm going to have 2 times all of this. This is why using the parentheses is important, because then you can see I need to distribute that 2. So I can't just multiply the 2 by the 2x. I have to multiply it by everything in that exponent. So on the left I would have 5x. On the right I would have 2 times 2x, 4x, 2 times -1, -2. So now this is one of those where I have variables on both sides of the equal sign. I want to get all my variables on one side. It's easiest if you move or minus the 4x, then you don't end up with a negative, minus the smaller one. So minus 4x from both sides. 4x minus 4x is 0. On the right side I'm left with negative 2. 5x minus 4x is x. So I have x equals negative 2. Now I think the other example in your notes, I can't remember the exact problem, but I know it looks like this, right? It has a fraction. And then I think we have a 3 on the other side. So I'm just going to make this up, I guess. I'm just going to do that. Might be different than the one in your notes. If you want, you can replace the one in your notes with this. So I want you to put a star by that problem, and I want you to tell yourself that whenever you have a fraction, you're going to have a negative exponent somewhere in your problem that you have to solve. So this is also a little, remember when we talked about this? Remember when we had negative exponents? And we said, oh, if you have a negative exponent, put your variable in a house, and the way you make the exponent negative is if it's upstairs, you send it downstairs, and the exponent becomes negative, and we put a 1. We basically take the reciprocal to make the exponent positive. So if it's at the top of our fraction in the numerator, we send it to the denominator, and that made it positive. So we can think about this the same way. The only different thing here that we're going to be doing is we're used to always getting rid of negative exponents. You'll see in a minute we're going to actually create a negative exponent because it's going to help us get our common bases. So you want to start out thinking, well, this is a base of 1 over 27, this is a base of 3, but those aren't the same. But just think about the 27. Can 27, kind of ignore that it's in a fraction for now, can the 27 be written as 3 to the power of something? And if you go to your cheat sheet and you go down the column that has the 3 to the x's, you're going to see that 27 is the same as 3 to the third. So I'm just going to write this as, instead of 1 over 27, 1 over 3 to the third. Left side for now, I'm going to copy job. Now I still have this fraction. The way I'm going to get rid of this fraction is kind of the same thing we did here. I'm going to say this 3 is downstairs, but I actually want it upstairs. So I'm going to send it upstairs, and when I do, the exponent is going to become negative. So that's different than what we're used to. We're used to getting rid of negative exponents. In these problems, you can see that creating a negative exponent actually works great because now we have a common base. Now remember, really, we have this. We send it upstairs, there's nothing left downstairs, so there's a 1. But when you have a 1 in your denominator, you can ignore that, right? Because dividing by 1 doesn't change anything. So now I have a common base, so I can ignore my bases, set my exponents equal to each other, and solve for x. So in this case, I get x equals negative 3 over 2. So if that's different than the one in your notes, it's the same idea. You can go ahead and replace that, the problem in your notes, with that one. I believe there was one other problem in your notes that also is not in my notes. I think I printed an older copy. So I will make one up. I'm going to make up this one. I'm going to say, let's think here. I think the one in your notes maybe had a 8. So I'm going to say 8 to the, I don't know, I'll just say 2x equals 32. Something like that. Okay, so this one, what's happening with my camera? This one, I don't know what's happening with my camera. It got dark.